Welcome to the day 4 video. Today we're going to talk about writing equations of functions. We're going to start by looking at the vertex form of a quadratic equation, which is y equals a, and then in parentheses the x minus h, close parentheses, squared, plus the k. We've already seen in this unit how valuable this form is, as we can tell what the vertex and axis of symmetry are, any translations that are made, the stretch or compression of the graph, and whether it has been reflected over the x-axis so that it opens up or down. The standard form of a quadratic equation is this y equals ax squared plus bx plus c. When we have a quadratic equation in standard form, we can complete the square to get it into this vertex form. So we're going to look at how to do this, but it is very similar to how we completed the square. So in exercise 2, we have a quadratic function defined by g of x equals 2x squared plus 12x plus 7. We want to write it in vertex form and show all the steps. So these steps are just like what we used to complete the square. We're going to group the terms with variables using parentheses. We're going to look for a GCF in A and remove it only from the terms in parentheses. Then we'll complete the square on the side and balance with the outside number. And then we'll turn the trinomial into a binomial squared and combine the outside numbers. So first, let's group the terms with x's. And when I look there, I can see that there's a 2 as the a term. So I'm going to divide that from both of the terms in parentheses. Once I have done that, the 2 will come out front, and the leftovers will remain in parentheses, but I'm going to include a blank to fill in for completing the square. I'm also going to leave it equal to g of x as it is here. We are not solving for the zeros, so that's the only difference between what we've done in the past. We used to be finding the zeros of the function. Now we're just changing the way it looks, so it's still going to be g of x equals. So I've divided out the 2, it comes out front. Then I'm left with x squared plus 6x and a blank to complete the square. Then the plus 7 and another blank to offset whatever I've put in parentheses. So how do we complete the square? Well, half of 6, and remember you can draw the picture of the square to help you with this. But if I have the square, I've got 6 groups of x, so to keep it even on both sides, I'm going to put 3 on each side. So that would mean I need 9 to complete the square. So I'm going to fill the blank on the inside with a 9. But although it looks like we've added 9, we have this 2 out front, meaning that I've actually added 18 because this is a positive 9. And I just added that there so we know it's a positive 9. We should really have a sign to show that those are 2 terms. So I've added 18, so that means that in this space I need to subtract the 18. And remember, that is doing that to complete the square with the 9. That is the half of b squared, and we've just balanced by putting the minus 18. Now we need to turn the trinomial into a binomial squared. So this, the whole point of creating this was so that it could look like a square again. And what's the side of the square? It would be x plus 3. So this trinomial is going to be replaced with x plus 3 squared. Still have the 2 out front, and now we need to combine the 7 minus 18 to get negative 11, so minus 11 on the outside here. And that's it. This is the vertex form. And again, why is this helpful? It's helpful because I can now see the vertex by taking the opposite of the inside. So the vertex here would be negative 3, and the same for the outside, so comma negative 11. I can see it right from the vertex form of the equation. I can also see that that means that it was translated left 3, then vertically stretched by a factor of 2, and then translated down 11 units. So that's why this vertex form is very helpful, so we can see all of those key things that have happened to our function. And we'll continue this more in class. Have a good night. See you tomorrow. And the last thing we're going to talk about is regressions. We've used these already. But as some reminders here, when trying to write equations of functions, it's helpful to know specific points that are on the function. Then you can put those points into L1 and L2 in your calculator. So remember, you go to Stat, Edit, if anything is in there, up, clear, down. Do not delete your list. And then you go to Stat, over to Calc, and then you can choose which regression you want to do, if it's a linreg, quadreg, or exponential reg. So recall from the past, when you are not told the function, you need to determine the type of pattern in the function. When we have a common difference, it's linear. Quadratics have a pattern we've talked about in the past of a common second difference, and exponentials have a common ratio. The number of points needed for the regression equations is we need at least 2 for a linear regression because there's only one line that will go through 2 points, but we need 3 for any of the other types of regressions. And we'll do more of this tomorrow. Have a great night.